So this current video would be a part two to the problem number two that we were working on. Got split up into two videos unintentionally, but that's fine. So we'll continue this. I think where we left off was, right, we had a slider or not a slider. We had a V-block clamp, um, which was somewhat properly constrained, right? It slides as it should. However, it does exit the block itself, which was I'm sorry, the base, which was a part of the one of the requirements for this problem was for it not to do that, right? So as I was mentioning before, we need to use an advanced limit mate to make sure this doesn't fall out. Uh, so what I would do is I would create a mate. Let's go to the advanced section, find the advanced distance mate, right? And now we need to make our selection. You know, what do we want to apply this mate to? In this case, I would say we should apply that mate to, let's say, the front plane of the base and also the front plane of the clamp. So we want to measure the distance in between these two planes. We want to set a max and a min to that, right? We want to make that within a certain range. So obviously, the minimum distance allowed would be 0, meaning the planes are lined up with one another. So we can set that to 0, right? Now they're perfectly aligned. What would be the max distance? Well, the max distance would be for when this plane, or for, I'm sorry, when the faces of these two components line up. So what I need to do for now is just set a max range. Just notice something. This assembly, even though the parts were made with inches, the standard units, this assembly itself was made with the metric units. So a cool thing, I mean, this is a good teaching moment, right? So a cool thing about AutoCAD, I'm sorry, not AutoCAD, I'm still stuck in that. SolidWorks is that we can enter a value with its unit. And even though it's not the units that the current document is in, it would convert that for us, right? So in this case, I want a value somewhere maybe close to the actual distance of the block is, right? Or half the distance. So the block itself is 4 inches wide. Meaning these planes, whenever it's at its max, should be somewhere more than half. So 2 inches is half. Uh, about 3 inches would be fine. And anything greater than that would be fine too. I'm just being kind of precise about what number I'm putting in here. Let's say I wanted to set my max to 3 inches. Current document is in millimeters. But if I type in 3 inches specifically, it automatically creates that conversion for me. So let me hit OK just to create the mate and then quickly change this to the correct units. So what I'm looking for here is what is the distance when this is at its max position? So if I move this, right, with that value that I set now, this is currently my max. I want to find the value whenever these two are lined up. So I could use a mate for that. Now, just because you create a mate doesn't mean you have to keep it. Like in this case, I can create a mate to make these two planes, or I'm sorry, these two faces coincident, right? So now if I look at this from the side, maybe you see these two planes line up with one another. So whatever this position is at currently, that would be my max. So if I go back into that advanced distance mate, I see now that whenever these two planes are 1.5625 inches apart, that should be my max value, not 3 inches. So you can just copy and paste this value into that. So that's my new max, right? Let me save these changes. Again, you don't necessarily have to keep this mate. I just added it to know when these two, or to make these two faces line up. So you can always delete it if you're using it for those purposes. Now, one issue that I did also notice was this would be my max, but if I try to drag it in the opposite direction, right, it doesn't let me. Meaning whenever those two are 0, Uh, it cannot go past that. So what I want to try is if my max distance in this direction is positive 1.56, uh, and 0 places in the middle, then logically speaking, when this gets to the other side, it would be the same distance, but in a negative value. So I want to see if this lets me do negative 1.5625 inches for my minimum value. Would you look at that? It does. So now I should be able to drag this again in this direction and also in that direction. And as you can see, with that limit mate, with that constraint that I'm adding, the clamp can no longer slide out of the base, which is what we wanted from this problem, right? So that's good. That's done. Now we need to constrain our screw into the clamp. So we already have our screw made. It's already here. This would be the first time you guys see a concentric mate. Can't recall if for the screw mate, does it, maybe it helps us. No, I think that's only for turning purposes. I believe before we do the screw mate, we should do a concentric mate, which would line up the screw with the hole, right? So again, and I'll demonstrate what I said earlier. Based on our selections, SolidWorks would allocate a constraint for us or a mate type. So let's say we wanted to constrain the face of the screw with the face of the hole. You see SolidWorks there, saw that both of my selections were round faces, so it thought maybe a concentric mate is what you're looking for. In that case, this works. So we finish this, we can see the added mate there. So let me fix this so it doesn't move on us. So now the screw is concentric with the hole, right? So that's good. But as you can see, the screw itself still passes through the clamp and it passes through the base. So we need to add some more mates there to fully define its movement. So let's see, what mate can we add? Let me move this back towards the middle. Let me float this again so I can move it. Oops, not what I wanted to click. I need to float this. Let me place this somewhere in the middle and fix it again. So I just want to see what comes into contact first, the screw head with the clamp or the screw shaft with the base. So I just click and move this right. I can see that the first thing to come to contact is the clamp with the base. So that's going to be my basis for I'm sorry, the clamp with the screw. That's going to be my basis for the limit mate that I need to make. So what we could do is we can use our move tool and we could use what's called collision detection. So collision detects us when two things are coming into contact with one another. In this case, I need to know when the screw contacts the base. So we have more than just those two components. So if you wanted to, you could be specific about which two components we want to see contact between, or you can do all components. In the case of a bigger assembly file, you do want to be specific about which two components it is because you have a lot of working parts. But in this case, it's pretty simple, so we can just leave it at all components. I'll show you guys how to do the specific components later. Let's say we had collision detection on between all the components. We want to make sure we stop at that collision. So whenever contact is made, we make sure we stop at that point. So now we can grab and drag our part. And it already started at a colliding position, right? Because the screw itself is already colliding with the clamp. So maybe we do want to be more specific about this. We want to specifically know when the screw comes into contact with the base, not the clamp, because it's already contacting the clamp, right? And you can see that. I just want to demonstrate that to you guys. Let's say I make this transparent. By the way, you can make stuff transparent if you right click on it, change its transparency. We can see that the actual screw itself is coming into contact with the clamp. As you can see, the hole of the clamp is smaller than the shaft of the screw at the moment. So it's always coming into contact. All right, so let's go back. Let's change the transparency again. And again, now I want to be more specific about when this collides, when the screw collides with the base. So I'm going to be specific. I want to say, I want to check the collision between the screw and the base only, not the clamp. Again, stop at the collision, and now we can resume our drag, right? So once we hit resume drag, you can grab your part, move it, and then we see, again, at that point, it stops the movement because they're colliding, and it even highlights what parts of it are colliding, right? So it shows us here that the screw shaft is colliding with these walls. So at this point, this would be our, depending on the distance made, this could be the one of the min or the max of the distance made we're about to make. So now that it's in a colliding position, right? This is the most it can go. Go back into our mates. Again, it has to be an advanced mate because we do want to limit standard mates specifically for distance and angle. Like just lets you set a standard value that cannot change. But since we do want to have that articulation, we want not just one value, we want a full range. So let's say, let's find some good, we could do a distance mate. Let's be specific about this. So the problem itself doesn't care about the screw being pulled out of the clamp. It says after completion, the screw should, on top should be able to screw in and out of the hole, and the clamp should be able to move back and forth. Okay, so we just need to limit this in one direction. What we could do, you can select any faces if you want to add your mates. I like to do planes in most cases, not necessarily in all cases. Like I could do the top plane in this case, right? Which in this case would be the exact same thing, just selecting the top face. But let's say in this case, we wanted to do the top plane of the screw, and let's find a good plane to select for the base itself. I would call that the top also on the base. We want to set a distance mate between these two. Now it's currently telling me that the current distance is this value based on what I selected. So if I click on my limit mate, I want this value to be my max or min. This should be the max distance. No, it should be the minimum distance, right? Because if we pull the screw out, this value is going to get larger and larger as the distance between the two planes gets larger and larger. So this should be our minimum value. They're only able to be this close together before stopping. Now, again, our max value in this case, it doesn't tell us that the screw can't come out of the clamp, which in an actual application, that's how it works, right? You should be able to unscrew this completely. So let's say our max value is something, for now, let's just say this is, how tall is the screw? The shaft of the screw itself is, oh, the screw itself is 4. So let's say 4 plus 4.5, maybe this should be rounded up like 10, just a nice even number, right? 10 would be our max. So now if I finish those changes, go back into the screw, and I pull this out until it hits 10, which is about this point right here, then it would stop, right? So this is our min, and this is our max. Doesn't necessarily have to be that far. Maybe you could just do it something like this. I mean, how it is now is perfectly acceptable. But maybe I want just a value that leaves it a little bit closer. So just moving it there and then checking our current value, maybe like 7.5 to have a nice flat number. 7.5 inches for a max value would work in this case. Cool. So now we have a screw that bottoms out. It's able to be pulled out to a certain extent. And why does I go that far? I thought I set it to be closer. So this is 7.5. All right, what are you at now? Oh, it's at 10. I must have changed the wrong value. I think I changed this one, which is its current position rather than its max position. So let's set the max to 7.5. Sorry about that. Cool. Now this should be it's freaking out because it's somewhere outside of its max. It's maybe I can let me hit Control Z. All right. So I undid that change. Let me first move it to somewhere within that range. Now it's somewhere within that 7.5 range. Now let me set the range to 7.5 and hit OK, save those changes. So now this is its maximum. Beautiful. It's perfect. It's exactly where I want it to be. Okay, final thing. Let's finish up this problem. So we have good articulation for this and its positions. We have good positions for this. Let me fix this again. But I want it to screw right. So currently it does not have any screw mate, which is the final part of this problem. So we want to add a screw mate, right? Which is under the mechanical tab. We find mechanical mates. Let's find a screw mate. Does it have like certain requirement? We know our threads on this paper say half by 20. We know the actual part itself is a half by 30. I'm sorry, half. I said that wrong. On paper, it's half by 13. We know the part itself was made with cosmetic threads that use half by 20. So what we need to do is understand what this half by 20 means. Threads, 20 threads. And what that half by 20 means is that the hole for the thread is ½ inch, and for every there are 20 threads per that 1 inch, meaning that there have to be 20 full revolutions of the screw to have 1 inch of linear travel. So let me hide this. So, okay, so that means, again, I have 20 revolutions per 1 inch of travel. You could also do the opposite, right? You can enter how much linear distance is traveled per that revolution. But in this case, we want to answer how many revolutions are required to travel 1 inch of distance. So we want to have this mate. Now, what two faces do we need to select for a screw mate? If I'm not mistaken, they should be similar to the concentric mate, which is the faces of the round face of the screw and the round face of the hole. So if we add that, let's just see what happens. Now, as we drag it down, you see that it's rotating as if it was being threaded into the clamp, which is exactly what it does. So if you either drag this down linearly, it rotates, or if you rotate the screw itself, it travels linearly. So now it has that correct screw mate. And also just based out of luck because I didn't really look into it, as it's being turned clockwise, right? It's being threaded into the clamp, and as we rotate it counterclockwise, it is being removed from the clamp. So threads are commonly right-hand threads, right? If you've ever heard the saying righty-tighty, lefty-loosey, that's what it means. As you turn right, it gets tighter, and as you turn left, you loosen it. So righty-tighty, lefty-loosey applies to right-handed threads. There are also left-handed threads, which do the opposite, right? They're threaded in the opposite direction, meaning if you turn right, you loosen it, and if you turn left, you tighten it. Which is also something you can change in the settings here. I believe there's like a reverse direction somewhere. Yes, so currently having reverse checked off means we're righty-tighty, lefty-loosey. If I were to uncheck this and save the changes, it would be the opposite. Now, it doesn't mention that in the problem, but with some common sense, let's stick to right-hand threads unless otherwise specified. It's the more common application. Left-hand threads, you'll see them few and far between. Cool. So now we have, I believe, all the mates done. Let's just give it a final check. So everything's floating minus the base, right? My clamp moves back and forth as it should without going past its limits. And now let me fix this because it makes it difficult to move both at the same time. Now this has a limit mate. It threads appropriately. And it also has a max, which is gonna take too long to unscrew it. So I can just go back here and just show the max. Let's say this changed. Let's change this to 7.5. Let's change this to 7.5 as well, or maybe like 7.4, right? I just want to show that it has an upper limit as well. So yep, there's your upper limit. So that would be the solution to problem number 2. Thank you for watching.